Hey everyone, today let's solve this power xn from LeetCode 50. The question says implement power xn which calculates x raised to the power n. Basically, you'd be given two numbers. One is going to be x and then the other one is going to be n. You can simply say that you have to calculate the power of x. Right. So in this example, 2 is given and then n is given. So 2 to the power 10 is going to be 1024. That is your answer. So how do you approach this problem? Well, one naive way to think about this problem is to simply, let's say you are given two numbers, x being 2 and then n being, let's say n is given as 3, right? So basically you are calculating 2 to the power 3. So if you break this problem down, it's basically multiplying 2 3 times, right? Basically multiplying 2 3 times. Well, to achieve this, you can simply apply one of the for loop linearly and then check your n. Your n is basically 3, right? Check your n multiple times, right? While n is greater than 0, you'd simply multiply your answer, initialize your answer by 1 and then multiply your answer by simply the value of x, and then after that reduce your n by 1, right? N minus equals 1. Dry run this to simply see what's gonna happen, right? So my right now my n is going to be 3. 3 is greater than 0, that's right. Then answer is going to be 1 multiplied by 2, it's gonna be 2. Now n is being reduced to n equal to n minus 1. It's basically 3 minus 1 equal to 2, right? Now the loop will go again here and then it's gonna check if n is greater than 0, that's right, because n is 2 right now. Now it's gonna calculate the answer again. My answer right now is 2. It will again multiply 2 with 2, it's gonna be 4, and then it's gonna reduce the value of n by 1 and it's gonna be 1. Now again it's gonna check if n is greater than 0. Yes, that's right, 1 is greater than 0. Then it will calculate the answer. Answer is basically 4, and then it will simply multiply 4 with x. X is our 2, so that is going to be 4 multiplied by 2 is our 8. Now it's gonna again decrease the value of n by 1 and n is going to be 0. But after that, as soon as it goes to check the condition, it doesn't meet, and then our answer is simply 8. It returns 8. Well, this sounds like a natural problem and then this should be pretty easier to figure it out. But the problem with this is that the question asks us that the given range of integer is basically 2 to the power 31 in positive, and then I think in the negative side it's going to be negative 2 to the power 31, the integer range, right? The value of integers can be on this range, which is very large number, but LeetCode only accepts values that are at max 10 to the power 8 operations. You cannot exceed this operation. If you exceed this operation, it will give you TLE. Basically it will give you TLE, time limit exceeded. So this is not the better way to solve this problem. You can also see it here. I have written it here, which says that any code that has at most 10 to the power 8 operations will not only be submitted on LeetCode, right? It will only be submitted with these 10 to the power 8 most operations. But the range of integer is 2 to the power 31, which is given in the code. If you can see it in the LeetCode. So the linear way does not work. I mean, it works naturally, it works if you think about it, generally it works, but the problem is that it doesn't work when you submit it in the LeetCode. And also the time complexity right now here is big O of n. So we have to think of some better ways to solve this problem. All right, now the same problem that we did using linear time complexity can be solved using this binary exponentiation technique. So before I tell you about this particular technique, I want you all to know that whenever you have a decimal number, like let's say you have a decimal number n, right? Let's say I represent a decimal number, whichever number, it can be anything, as n. The binary representation of that number will exactly have log base of 2n plus 1 digit. So let's say you have 5 is in. If you convert this binary, sorry, the decimal into a binary format, it's going to be 10, sorry, it's going to be 101, right? Now if you see, if you count the digits in here, you have 1, 2 and 3. So if you apply this formula in any decimal number, you will exactly get log base 2 of n plus 1 digit, which in the case of 5 it is 3. It has 3 digit in 101. Let me make it clear here. Now the reason that we are using binary exponentiation is pretty simple. It obviously converts our time complexity from big O of n to big O of log n. How? Well, let me show you. Instead of looping here, instead of looping 5 times on this number, in this particular number, we converted this 5 into its binary representation, which is going to be 101. And then instead of looping on this particular value, we will start looping on this value. So if you used a linear loop, it's gonna it's gonna it's gonna take you 5 times to run the particular value and then get its binary exponentiation, or the power x to the power n. But if you simply convert that particular 5 value in binary, you will loop in this binary value. Now how are you going to do it? Well, if you see it here, now you have binary representation 101. So the first step is to convert your decimal to binary, right? The decimal will be converted to binary, and then remember that instead of looping in the decimal format, we will start looping in the binary format to get log n time complexity. Now if you see it here in this 101 example, this particular value is represented it as x in the decimal format. This particular value is particularly represented as x square, and then it goes on doubling, x to the power 4, x to the power 8, x to the power 16, like that. It goes on and on by doubling it each time on the particular value from left to right, sorry, right to left. If you had any value here, it will simply be x to the power 16, x to the power 8, like that. It goes on and on. So what I'm trying to say is, if you have 101, which is a binary value, this particular place can be represented as x square. This can be, sorry, this is x, not x square. This can be represented as x square, and this particular value can be represented as x to the power 4. Now if you see it here, you have 5, right? You have x to the power 5, which basically means you have 3 to the power 5. I'm taking x as in 3 example here. Now if you break this down, you can find 3 to the power 4 and 3 to the power 1 here, right? If you simply try to multiply this, your answer will be 3 to the power 5 itself. So you will get the same exact value if you break this down. Now if you try to put those value here in this place, you can put 3 here, 3 square here, and then 3 to the power 4 here. Now you have to ignore this 0 here, because if you see it here, 3 to the power 5 is basically 3 to the power 4 and 3 to the power 1. So you simply ignore your 0 value in the binary representation, and then multiply these two value, which is 3 to the power 4 and 3 itself, and you will get your value as an answer, which is 3 to the power 5. So how can we do this in code actually? Well, let's see. We can take one variable as a binary form, and then we will assign our n value, which we have x to the power n here. Let's see, 3 to the power 5, and then I'm assigning n itself to the n, to the binary value, right? Now I will loop until my binary form becomes 0. So it's going to be binary form is greater than 0. While binary form is 0, this loop will continue while binary form is 0. Now I'm going to check if my binary form that I have right now is not equal to 0. That means if I, so initially I said that we will be converting our binary or the decimal number into binary number, right? So I mean, in that case, I wasn't saying that we will completely use different formula or different function to calculate the binary function. Instead, we can simply modulo the particular binary form that we have, which is 5, with 2, and then we'll get 1 here, which is simply, if you convert that into actual binary format, we are getting this particular value, which is at last here, if you modulo with 2. So that's the idea that we are using in a binary format. Now, if that value is not 0, right, which is other than 0, which is 1, if that's the case, then I will multiply, or I will add that in my answer. So my answer is going to be answer multiplied by x. What does x represent here? Well, x is a value which is 3 here. So answer was 1. Simply assign your answer to be 1 here initially, and your x value is 3. So in your answer you have 3 right now. All right. Right after you complete your binary form, or check this particular scenario, you have to multiply your x value by itself. X equals x multiplied by x. Well, why are we doing that? Well, the reason we are doing it is because I showed you earlier, we represented each of the position in the binary form with x square, started with x, sorry, goes to x square, x to the power 4, like that, doubling, right? And we have to do the same thing here. And then we already ignored 0. Whenever we have 0 in our binary digit, this won't run, but we have to double the value, because in this case, even though we didn't get this particular value, we have to get the other value by doubling it. So that's kind of idea. After that, you also have to divide your binary form by 2 in order to get the next binary digit. Well, what does this mean? Well, initially you have your binary form is 5, right? When 5 modulo 2 equals 1, you still have 5. Now, in order to get the 0 value, the simple binary form of 5 is 1, 1. You are getting this particular value at this time, 1, right? But what if you want to get 0 next time? Well, in order to do that, we have to simply divide our binary form with 2, and then in C++ it's going to be 2. Now, in another case, in another iteration, your 2 will again be divided by 2, and then you will get 0 here, right? Now 0 won't be calculated because that doesn't contribute to our answer. Again, we will divide this 0, which we already got 0 here. Again, we already divide this 2 by 2, and then we'll get 1, which is our first value, right? And then we'll add that up in the answer. So that's the idea that we're doing here. Okay, so let's hop into the LeetCode, and I'm going to code this up, and then it's going to be more easier to understand you on what am I doing. All right, so let's code it up. So initially I'm going to assign my answer to be 1. Answer is going to be 1, and then I'm also going to be assign my binary form, which is I'm going to assign as long, because integer can be integer value simply can overflow, and that's why I'm going to assign long in my binary form, and that's simply going to be my answer. Now, while my binary form is greater than 0, I'm going to check if my binary form, which I have right now, is not modulo 2 is not equals 0. If it is 1, then only I will add that up in the answer. So answer is going to be answer multiplied by x. After I calculate that, I have to double my x value by doing this square. So x multiplied by x, right? After I successfully calculate that, I will simply return my answer. So that's the idea of simple code of my power, or power x to the power n. But there are some edge cases that we're missing. So the first edge case I want you all to think about is, let's say you had your x value to be whatever, right? It doesn't matter, like let's say you have n is x value. Oh, it's going to be confusing. I'm going to say simply 3. Now let's say you have n equals 0. Now, what does x to the power n represent here? Well, it's basically 3 to the power 0, right? And then you have studied from simple mathematics in our class that whatever value raised to the power 0 will always be 1. So we will give a check here. If at any point, if our n is going to be 0, will simply return 1 as an answer. So that's the idea. Now, the other thing is that what if your x is 0 and then you have n is like, let's say, value whatever, like let's say 12, right? So 0 to the power 12 is basically going to be 0. So whatever number you have, when x becomes 0, you will simply return 0 from there. Now you also have to handle other edge cases. What happens when you have x as 1? So 1 to the power something will always be 1, right? So in that case, you will also do, if x equals 1, you will return 1 as an answer. Now what happens when you have x as a negative 1 and then you had your even n? So what I'm trying to say is, if you had to calculate negative 1 to the power 2, what would that be? Well, that's simply 1, right? So the idea is, whatever negative number raised to the even number will always be positive. So in our case, if x equals 1 and sorry and the given number, if it equals to 0, then we'll simply return 1 from there. But what if it's going to be negative 1 here? My bad. But what if x equals negative again and n modulo 2 does not equal to 0? That means it's odd. Well, in that case, we'll simply return our negative value as negative 1, right? So that's the basic idea. Well, we handled almost for x and n, but we have missed still one thing. So let's say you have n as a negative number, right? So let's say you have n equals negative 2, and then let's say you had to calculate for 3. Now it's calculating 3 to the power negative 2, which is basically going to be 1 divided by 3 to the power 2, right? So we have to modify our format whenever we get our n to be less than 0. If it's negative, then we have to say that our binary form will also be negative, negative of n. Well, what does that mean? Well, if you see it here, 2 was initially negative, right? Negative 2. But if we convert that into reciprocal, or if we convert that value into denominator, it becomes positive. So we're assigning binary form to the negative of n, which basically is positive because n initially is negative. And also we have to convert our x value to 1 by x here, if you see it here. So we'll say x equals 1 divided by x. All right, so that's it. So I think everything should be good and everything should be submitted clearly. Let's try to run this and then submit it. Okay, let's run. Uh-oh. Undeclared identifier. We got undeclared identifier. What does that even mean? Let's go to the code. Let's see here. Binary form is not declared. Oh, we had to declare this value before here. Okay, I think it should be good now. Let's check. It's taking a long time. It's taking time limit exceeded. Why? What did we do wrong? Oh, if you see it here, we missed to divide our binary form by 2. My bad. If we miss it, then we won't be calculating any value. So we have to think about that too. It happens. I mean, we forget, we are human beings, right? Ooh, still got negative, 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 negative. No, 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 no. What did we miss? A couple of things that I missed here. I had to initialize this answer as a double, which is a float value, because the answer is expecting us to return the double value. I missed that. And also I have, since I have already initialized my n value to be a binary form, so I have to basically change the binary form. Hopefully this should run now. Let's submit. Let's try to run this and then submit it again. Test cases are here. So all of the test cases have been submitted. So let's submit this code up. Let's see. All right, so this has been accepted, and then we have beaten 92.50 percentage people. All right, so I hope you understood something from today's video. I'm gonna be uploading these kind of videos anytime, maybe tomorrow or the day after tomorrow, because I have a whole bunch of like 20 videos already been covered, but I haven't tried to edit it. So yeah, see you, bye.